Hi, and welcome to our joint webinar with TrustInSoft and SolidSense. Joining me today, we have Roland and Remy. And before we get started, I would like to provide you with some housekeeping rules. The webinar is being recorded, and we ask you to hold if you have any questions. You can still submit them on the Q&A. However, they will be addressed at the end of this session. The recorded version will be made available for you in case you would like to follow up, and that will be in a couple of days. With that being said, let's get started with achieving secure libraries with SuperTest and TrustInSoft Analyzer.
Thank you, Ludmila. I will start with a short introduction to SolidSense. We are an Amsterdam-based company from the Netherlands, and our mission is to make the world a safer place. We do that by being the world-leading provider of verification and qualification technology for C and C++ compilers and libraries. We support our customers with achieving the highest quality in terms of tools, as well as libraries, and also with ensuring the safe use of those tools and libraries. Our main products are SuperTest, which is our overall test suite for the C and C++ compilers and standard libraries, and SuperGuard, which is our safety qualification suite for the C and C++ standard libraries. We provide our test suites to tool vendors and semiconductor companies who use our test suites for the quality assurance and the safety qualification of the tools, libraries, and analysis tools that they develop. And on the other hand, our products are also used by many developers of safety critical software in order to ensure that they use their compilers, libraries, and tools in general in compliance with applicable functional safety standards. So, for example, we support developers of automotive software, robotic software, railway software, making sure that those software systems are safe also from the perspective of the tools and libraries that are being used. With our products, you have the flexibility to test and qualify compilers and libraries for specific ways of using them, so your specific use case, even if those tools and libraries are open source. And yeah, altogether, our products and services ensure that the testing and the qualification of compilers and libraries is as straightforward as possible. So now that I introduced SolidSense to you, I will hand over the mic to Roland, who will introduce you to TrustInSoft.
All right. So Roland Dumaine, responsible for solutions engineering. TrustInSoft is a French company established more than a decade ago. The technology that is at the foundation of our products is something coming out of the French CEA, Atomic Energy Commission, and we have customers all over the world, and also in all kinds of markets, going from the critical markets, automotive, but also consumer electronics, mobile phones, the playing devices, and in general, any device that needs the highest levels of robustness, security, safety, or combination of. Where static analysis would try to actually achieve to give you some information, TrustInSoft Analyzer is actually a provable tool that will give you all the remaining issues that are relying in your code. If we take a step back and look at the wide market, there are many challenges ongoing, and again, it is happening in many markets there. When you have safety requirements, these safety requirements always become more stringent, nevertheless. And reliability in general, even if you don't have safety requirements, are always something that you have to maintain anyway. At the same time, most embedded systems are also connected, and cybersecurity is now not just something that you may look at eventually, but becomes central in the general behavior of all the devices. So you have to solve that and make sure that no critical bug remains after shipment. At the same time, you don't just have to do a good job, but you have to demonstrate often a good job in many markets, there are some regulations that forces you to follow international standards and even reach certifications to be able to demonstrate that you did a sufficient work for making sure that your product can be shipped on the market. And at the same time, always ship faster and more efficiently. So things always get more and more complex, more and more critical, with added regulations that never become simpler. And um, as systems become more complex, it's becoming higher. It's if you don't change the methodology, or if you don't improve at least the methodology, that means that you will have issues. Um, Here are two automotive issues, which are real life issues. If you work in the automotive field, you will probably agree that these are real, but actually these are just two examples. It's very typical that after deployment of a critical system that would be connected, for instance, or just in general, when you have a system that requires high robustness, even lower business or anything, there are situations where when the number of deployments are high enough, there will be a higher risk of systems malfunctioning. So you have to make a strong work to avoid them. But typical studies show that typical issues revolve around the topics of buffer overflows, variable or arithmetic overflows, and the difficult ones that remain after you ship are typically not the easy ones, but the ones that appear after hours or even days of operation. So you need methodologies to find those deep issues. Another example would be a memory corruption, which is similar but different in that a memory corruption would typically appear appear once you consolidate your system. And so during design verification, once you do your original your first field test, you may actually do additional issues and pressure the system and actually find issues like memory corruption that may cause a crash. The worst kind is actually the kind that will not cause a crash immediately, but will cause a crash after days or weeks. That means that you will have to spend also a huge amount of money to try to reproduce the bug in the first place. Well, what's the reason for all that? There are many reasons, and we don't claim to eliminate all the bugs in your software. After all, this is where engineering is still required. However, there are categories of bugs that just don't come from a bad specification, but really come from the inherent form of the language that you use to code. In particular, C and C++ are very good languages to express things and complex applications, low-level applications, even sometimes higher level that scale very well. But they have voluntary limitation in the language. C and C++ are not safe languages. So what can you do about it? Well, there are technologies that can allow you to actually find all those hard to find issues. TrustInSoft Analyzer is one of those. It's a hybrid code analyzer that actually has technical requirements looking like a static analysis tool in the fact that you run it on a PC, you do not need the real hardware to run it, but it will also show diagnostics related to what a dynamic analysis would bring you. In particular, it does what we call value analysis using the abstract interpretation technique to basically evaluate all your code by taking the data inputs that you give it and understand how that data will evolve through the graph of your code. It's not just trying to do that, it's actually following the formal verification process. So, and the tool is meant so that you can actually we can demonstrate that we find all the bugs of the category of issues that we search for. The last part, and I'm showing it on this slide here, is that the tool is generally providing you with a command line output and reports and also HTML report. But when the time comes that you need to understand in detail what is going on, we also provide a more interactive root cause investigator to be able to look at what is going on and actually reach the real root cause of the issue. What makes TrustInSoft Analyzer very specific? Well, as I said, it focuses on the difficult issues that are not necessarily the functional issues that you define in an arbitrary way as the main function of your device, but actually it focuses on the other issues, the unintended behaviors that are happening in your software that would be happening when you run it in the field, and that are generally named in C, C++ undefined behaviors. And those would be typically buffer overflows, arithmetic overflows, memory corruptions, and so on. The tool has one important property, which is soundness. Soundness means that the logic applied by the tool makes it capable to catch all the issues evaluated. So no bug is ever missed. That's a strong guarantee because in comparison, typical static analyzers will only claim they tried. They use rules to detect forms of code that would be wrong, but they don't claim to have found everything. They don't claim to find only real issues. In the case of our tool, we do claim that when the tool does not find any alarm in your code, there are no such issues remaining for the given input. As a consequence, as a developer or as a tester or as the person doing the code verification, using that kind of tool leads you to a very high, very low fatigue, meaning when the tool reports something, you have to look at it. But that's not the end. The tool also gives you a measure of which code paths were reached. And that means that you can use it in the context of safety evaluation. And you can actually, because the tool is qualified for safety, you can actually use that to provide evidence to your safety assessor. And that means you can reach up to 100% code coverage and quickly identify which code paths are not reached and resolve that. As I mentioned, there's also the root cause analysis tool to be able to interactively look at everything that's going on. That wouldn't be helpful if there wasn't the support for the specific architecture of your choice. So whether you're running for ARM, x86, but also in the case of RH850 or RISC-V, Oryx, and all the other architectures that you want, the tool will take into account the specific architecture that for taking care of detecting the specific issues that would be related to pointers, for example. In your specific software, you can also add the support for describing the memory mapping of your environment, which is great when you want to analyze device drivers and talk to hardware.
All right, thank you, Roland, for introducing us to how bugs can be eliminated from application source code. As we can see on the slide, that is exactly where the analyzer has you covered. So it makes sure that in the code that you write, there will be no bugs. But yeah, one question still remains, and that is, what about the compilers and the libraries that you also heavily rely on? Because in order to obtain usable software, your code will always go through a compiler in order to obtain code that can be executed. So no matter how well written your application code is, you still heavily rely on this compiler to translate your code without making any mistakes. So in other words, without introducing bugs into your application code. Likewise, your application may call functions from the standard library, which is code you did not develop yourself. And if you don't do this with care, also those functions may introduce bugs or even vulnerabilities. So in other words, the compiler and the library are still two very significant factors that may introduce bugs into your software. But luckily, that is where SuperTest has got you covered. SuperTest ensures that both the compiler and the standard library that you rely on are well tested and also fit for use. So SuperTest is a very large test suite of both handwritten and generated tests that verify the implementation of any C or C++ compiler or standard library implementation. And as you can see in the graphic on the right, It supports up to the latest version of C and C++, with support for the very recent release of C23 currently being in the works. The benefit of C and C++ as languages are that they are ISO standardized languages, and that means that they are very extensive and well agreed upon documents that not only specify how the language should behave, but also specify the functionality of the standard libraries. Now, based on those standards, at Solid Sense, we developed the test suites that are part of SuperTest, and those test suites verify conformance of compiler and library implementations to these standards. Each test can be traced back to the standards as well, so it is clear what is being tested. And at the same time, this also provides traceability that makes sure that the test suite is complete, and therefore, you don't have any gaps in the test coverage in terms of functionality. It is important to note that SuperTest goes far beyond just conformance testing. We have a background in compiler development, so we know which aspects of compiler internals need to be tested with extra care. And some of these aspects are not even mentioned in the C or C++ standards, but still they are very important to be tested. An important example are compiler optimizations, which rewrite your code to make it more efficient. And the only thing the standards really say about optimizations is that compilers are free to optimize your code as long as they don't change the observable behavior of your program. So it is very important to verify that the compiler is doing this correctly, because rewriting the code could easily introduce bugs. But luckily, with the dedicated optimization test suite of SuperTest, we ensure that also these aspects of the compiler are tested extensively. Likewise, SuperTest has extensive testing for the front end, for the back end, for data models, and many other compiler internals that are definitely important to be verified. In the end, everything comes together in the easy-to-use test driver that automates the testing, in the comprehensive reports that present the test results to you, that also provide the traceability that I just talked about. And altogether, this makes the SuperTest the industry standard for C and C++ compiler and library verification, and also for the safety qualification of compilers and libraries. So now that I've introduced SuperTest to you, let's reflect again on these development challenges that Roland introduced today, and see how SuperTest tackles these challenges from the perspective of the compilers and the libraries that you rely on. Well, first of all, when we talk about the increasing safety and reliability requirements, here SuperTest has you covered right from the start of your development process. SuperTest can guide you in the selection of the right compiler and the right library to use for your project. And by assessing the quality of compilers and libraries during your selection process, you ensure you select a reliable compiler and a high-quality library that can be used throughout your project. And even if the compiler or library is not perfect, because in practice with SuperTest we always find some issues, you will be aware of those issues right from the start of your project. And developing your software with these issues in mind means you can work around them. And that is definitely a lot easier than retroactively patching your code later on in your development process. In terms of safety requirements, SuperTest got you covered too, because it can be used to qualify compilers and libraries for use in safety-critical software development. SuperTest ensures compiler and library compliance to international functional safety standards for automotive, for industrial, for railway, medical, and many more areas of safety-critical software development. So that way, also the increasing safety requirements are well covered. In terms of the increasing costs and development times, you definitely save a lot of time by selecting the right compiler and the right library early on in your development process. Because if you use a high quality and a safety qualified compiler and library right from the start, you develop your software with these properties in mind, with these safety guidelines in mind, and you don't have the overhead later on in your project of reconfiguring your build system or patching your code that you would need to do if you only select the final compiler and library way later on in your development process. Now, that only leaves one missing piece of the puzzle, and that is the increase of cybersecurity threats. Because how do you know for sure that the library that you rely on does not introduce vulnerabilities into your code? So like I just said, with SuperTest, you at least make sure that the functionality is verified. You know that the library is doing what it is supposed to do. But how do you make sure that no vulnerabilities are introduced? Well, that is where SuperTest and TrustInSoft Analyzer together are coming in. Because that way, by using the two products together, you can detect and prevent vulnerabilities from being introduced by libraries.
And that's exactly what I intended to. Yeah, that's exactly what I intended to interrupt you with. But then the flow was good. Is that this analyzer TrustInSoft will help you to find all the unintended behavior, while SuperTest will help you to actually confirm that everything is working as intended.
Exactly. So yeah, here SuperTest and TrustInSoft Analyzer really complement each other. So yeah, let's go through some of these aspects that demonstrate this. Well, the first item is, yeah, exactly what Roland just mentioned. SuperTest verifies the functional behavior is correct, while TrustInSoft Analyzer detects vulnerabilities. So yeah, we verify with SuperTest that the library is doing what it is supposed to do, and the TrustInSoft Analyzer verifies it does not do anything in addition to that, which you don't want it to do, like a vulnerability that is suddenly being introduced. Next, yeah, the test cases in SuperTest have high code coverage of the library out of the box. And on the other hand, TrustInSoft Analyzer utilizes that high code coverage because the analysis that it does is accelerated by using existing test cases. So yeah, using the existing test cases from SuperTest, you will more efficiently and quickly exercise and analyze the library code. The other way around, TrustInSoft Analyzer also reports the achieved code coverage, like Roland just talked about, which also means you can analyze the coverage of the library code. And this can then be used as evidence of the completeness of the test cases in SuperTest. So again, yeah, here they really go hand in hand and they complement each other. Finally, SuperTest supports any C or C++ standard library implementation for any target. Likewise, like Roland introduced before, TrustInSoft Analyzer supports the accurate emulation of on-target execution. So that means that both products are ready to work with your library, no matter if you're developing software for an embedded device or a system running a fully fledged operating system, no matter the implementation or the target. Yeah, with SuperTest and TrustInSoft Analyzer, it will just work. So now let's go back to Roland. We will dive into the process level savings that are brought to you by using the two products together throughout your development process.
Right. So in principle, when you do that verification, this will have an impact because when you do find issues, you are able to actually identify them quite early in the process. So whether your focus is functionality, safety, or security, that means that finding those issues earlier will save time on the later activities and actually lower those later activities risk a lot. In general, that means that you find problems earlier where they are cheaper to resolve, rather than finding them late, as I was mentioning earlier in this presentation, where when you reach the field test, or even worse, once you have deployed, repairing the situation will require an extensive effort if it is at all possible. So in terms of technology, both SuperTest and TrustInSoft Analyzer allow you to do a high quality job, but the perspective of using them combined actually saves a lot of effort in the overall validation of your software in general. So when you consider the solution you want to use for validating your software, it's always useful to understand not only how the tool and how the tool works and what the tool can achieve, but also the side impacts of doing that kind of activity later down in the stage of the the V model. This is the end of this presentation. Again, as a last point here at the top of this slide, each solution can be used independently, but the combination of both actually helps you bringing safe and secure software and libraries. Since this is the end of this presentation, I think maybe if you have questions, you can write them in the Q&A, and we'll be happy to answer them if there are any. Ludmila, you're muted.
We actually have one. Do you have an example of a known vulnerability in a standard library?
Yeah, I think I can answer that. Yeah, as a theoretical example, I think what we can say is that many different library functions are prone to vulnerabilities because they operate on pointers, they operate on memory, and that is typically where vulnerabilities come in. Depending on which library you are using, of course, I mean, the C and C++ standard libraries, they have many different implementations. So it really depends on which implementation you are using, whether you have a vulnerability or not. So we cannot say there's one vulnerability in every C standard library because that's simply not something we can say. But in practice, what I know is that there have been quite some CVEs, which are these vulnerability reports for the open source libc libraries, for the muscle libc library some years ago, where, for example, a print function was using some temporary buffers where it was writing out of bounds, and that could be abused by people that want to breach into your system. So yeah, there are many possible examples, but also practical examples where this happens. So to really make sure that you are not impacted by it, you would really have to analyze the library that you are using and make sure that that does not introduce any issues to your code.
And I will relay that in a in a very strong way, because typically the C and C++ standard and the implementations of those standards focus on making sure that the defined cases are working correctly. And actually, this is what SuperTest helps you figure out. Actually, for the rest, then the implementers of the libraries try to do their best to actually produce a meaningful state and answer. But as it's actually not defined, they're free to do anything, including do something that would be dangerous for the application or even crash. In some situations, actually crashing may be the right thing to do, so you fail early. But first point is, those vulnerabilities may hide them, and usually hide in the undefined areas.
We have a second question about the code coverage. Does it also include MCDC coverage? Also, does the tool help find the adequate values to reach the missing coverage, or only provide the line's branches?
So this analyzer, and that's part of the safety qualified part of the tool, does provide line, statement, function, and branch and MCDC. So that's the full scalability of it. And actually, for us, this is a logical outcome of the support of that tool, because the tool will go through the code through each statement of your software. So as a consequence, we just have to write down which code path we reached and then report it to you. So the answer is yes. But however, no. Sorry. Go ahead.
We have a third question. Thanks for the interesting talk. Can you help me understand whether the TrustInSoft detect issues of the code statistically or dynamically?
So again, the analyzer will run on a regular Linux PC. It only requires CPU time and memory. It does not require the physical hardware. So in that way, it looks like a static analyzer. However, the methodology used by the tool is to evaluate and kind of the abstract interpretation approach with value analysis is looking like a simulator execution. So it will actually compute, based on the provided inputs, all stages of the symbols throughout your application to consider what the outputs will be. And so that's why it looks like a dynamic analysis, in the perspective that it will compute the output similar or identical to a real execution. In particular, this can help identify complex issues related to pointer calculation, where the typical static analysis tool will not be able to conclude anything. And because TIS Analyzer will track the value of each symbol, including pointers, it will be able to guide you and find issues related to bad handling of those pointers.
Well, thank you, Roland and Remy. That's all for today, and hope you all have a great evening, rest of the day. See you next time.
Thank you very much. Bye-bye.
Thank you. Bye-bye. And feel free to contact us if you have any questions.
Of course.